We're going to begin Unit 2 with Section 4.1, Introduction to Fractions and Mixed Numbers. Most of us know that fractions are used to measure a part of the whole. Fractions have two parts, a number on the top and a number on the bottom. The number on the bottom is called the denominator, and it's the number of equal parts in the whole. Or we can think of it as the kind of part. If it's divided into two parts, then their halves that is divided into three parts and a thirds. The numerator, the top number, is the number of parts we're being considered. That is shaded or whatever we're talking about. If 3 out of 9 people, then 3 would be the number we're considering. Fractions whose numerator is an integer and whose denominator is a non-zero integer are called rational numbers. The bottom number, nothing can be divided into zero pieces. If you have a thing, you already have one part. We'll talk more about rational numbers in a later unit. Remember, the fraction bar means division, and since division by zero is undefined, a fraction with a denominator of zero is undefined. These are things that we know about numbers. A number divided by 1 is equal to that number. 0 divided by a number is 0. We can't divide by 0, so that's undefined. If the numerator and denominator are the same number, or the dividend and the divisor, then the answer is 1. If we have a negative numerator and a negative denominator, that's division and the signs are the same, so it would be the same as a positive fraction. This really belongs over here. Sometimes you will see a fraction, like in the answer key, you'll see a fraction with a negative sign in the front. That can be either a negative numerator and a denominator, or a positive numerator and a negative denominator, because here the division signs are different, so the answer is negative. Okay, now we're going to write some fractions. This is like going to first grade. So if we look at this first drawing, our denominator would be 3 because the fraction's divided in, or the whole is divided into 3 parts. 2 are shaded, so 2/3. In this picture, we have 5 parts in the whole. 2 are shaded, so 2/5. In this last one, we have 8 parts and 3 are shaded, 3/8. Now we're going to do a little drawing. If we want to draw 5/6, we need to draw a hole. I'm going to do a circle, and now I'm going to divide it into 6 parts. We have to assume that these are equal parts. Mine probably are not so much, but we'll pretend like they are. And if we want 5 of those 6, we will color in 1, 2, 3, 4, 5, 5/6. If we need to draw something to represent 3/8, then the whole will be divided into 8 parts. This one looks like it might be a little better. And we're going to talk about 3 of those, so we'll shade in 3 parts. And it really doesn't matter which 3 that we shade in. Next, we're going to continue to work on some vocabulary. We're going to talk about proper and improper fractions. A proper fraction is a fraction whose numerator or top number is less than its denominator or bottom number. So this would be a proper fraction, this would be a proper fraction, and that proper fractions are less than 1, as you can see. If the numerator is smaller than the number of pieces in the whole, then it's not going to be more than a whole. An improper fraction, on the other hand, is a fraction whose numerator or top number is greater than or equal to its denominator or bottom number. Improper fractions are greater than 1. That's left off of our copy. So when we look at these examples, would this be proper or improper? Well, the numerator is bigger than the denominator, so this is an improper fraction. This one, the numerator is smaller, so it's proper. And this one, the numerator and denominator are equal, so we say that this is an improper fraction as well. Now we're going to write an improper fraction to represent the shaded area. Now, this is sometimes kind of tricky for students. This is one whole, and each whole is divided into 4 parts. So we have 1 whole, 2 wholes, and a 4th. That would be a mixed number, which we'll talk about in a moment. But if we're writing it as an improper fraction, the denominator is 4, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 fourths. So that's an improper fraction because the numerator is greater than the denominator. So now let's take a look at mixed numbers, which we just wrote. In general, a mixed number is the sum of a whole number and a fractional part of the whole, like this. We usually don't put the little plus sign in there, so we don't write it as this. We just write it as 2 and a 4th. So let's look at this. Here we have 2 whole units, which would be 2, and then this piece that's only partly shaded, it's divided into fourths, and we have 1, 2, 3. So this is 2 wholes and 3 fourths, which we would have 4 fourths and 4 fourths. So we have 2 sets of 4 fourths. This is incorrect in your copy. Plus this 3 fourths, which would be 8 fourths plus 3 would be 11 fourths. So this is the little algorithm or the rule to do that. We're going to multiply the whole number by the denominator because we have this many sets with this many in it. Then we're going to add the result to the numerator, and then we'll write the result from the second step over the denominator. So if we have 7 and 1/4, we have 7 sets of 4, which is 28, plus this one more would be 29, and we write it over. We're talking about fourths. This one is going to be negative, of course, and we're going to have fifths. We're going to have 8 sets of 5, which is 40, plus these 2, which would be 42. So negative 42 fifths would be the same as negative 8 and 2 fifths. Now, if we want to go the other way and we want to go from an improper fraction to a mixed number, we want to just remember that the fraction bar means divide. So we're going to divide 25 divided by 6, which goes 4 times, which uses 24 with 1 left over, and we would have 1/6. So once we divide, the 4 would be the quotient, 1 would be the remainder, and we would write it over the divisor. So we would have 4 and 1/6. If we have 39 fourths, that's 39 divided by 4. That goes 9 times, which uses 36. We have a remainder of 3. So we would have 9 and 3/4. This is the remainder. This is the divisor. We have 14 fifths. That's 14 divided by 5, which goes twice. Uses 10, and we have 4 left over. So 2 and 4 fifths. This is negative, so we know that our fraction is going to be negative. And we have 95 divided by 11. We know our 11s, right? 11, 22, 33, so forth. So this would be closest to 8, which is 88, with 7 left over. So negative 8 and 7/11. So here we're dividing by 25. The quotient is 24. 21. The remainder is 4. And this should be 25ths. Now let's look at this on a number line. If we want to show 1/2 on our number line, then we're going to have to divide this distance between 0 and 1, or every whole number, into 2 parts. So this would be 1/2. If we wanted to show this on a number line, we're going to divide the distance between 0 and 1 into 6 equal parts, because that's our denominator. So I'm going to divide it in half. Then I'll divide each of those into 3 parts. And we're looking for 5, 6. So 1, 6, 2, 6, 3, 6, 4, 6, and this would be 5, 6. So if we want to show this on the number line, that's an improper fraction, so it's going to be greater than 1. So we're going to have to do some busy work here. So we're going to divide the distance between each whole number into 4 equal parts, into 4 equal parts, into 4 equal parts, into 4 equal parts. And now we're looking for 13 fourths. 1 fourth, 2 fourths, 3 fourths, 4 fourths, 5 fourths, 6 fourths, 7 fourths, 8 fourths, 9 fourths, 10 fourths, 11 fourths, 12 fourths, and here is 13 fourths. Now let's talk about absolute value and the opposite of a fraction. We've done this with whole numbers. Remember, the absolute value is either positive or 0. And the opposite of a number, you change from plus to minus, or from minus or negative to plus. So these fraction bars are absolute value. And so we're going to make it positive. So it's going to be 12/5. Here we have absolute value of 3/7. It's going to be positive 3/7. This is the opposite of the absolute value. So the absolute value would be 3/4, and we want the opposite of that. So it would be negative 3/4. This last one does not have the absolute value bars, but instead has parentheses. So we're talking about the opposite of negative 3/4, which would be positive 3/4. So you can kind of review that back in the previous unit.